Hey class, I wanted to go over number 1 on the homework. It's one of the more difficult ones, actually. That probably means I didn't do a good job on my instructional video, pre-class instructional video. So this will give me a good chance to hit these ideas again, perhaps in a slightly different way that can help you out. So number 1 says find the orthogonal complement of this set, this subspace. So the orthogonal complement is all of the it's all of the vectors that are perpendicular to any vector in the vectors in the subspace. So there's two different ways we can think about this. One, since it's given as an equation, we can think about this in terms of the geometry of the Cartesian plane, and I can write this line as a slope of, oops, I made a mistake. This is the line y equals 2x, so that's what I'm working with. I'm not working directly from here, but I know how to graph that fairly easily. Y-intercept is 0, slope of 2. So that's what I was doing. Okay, so so we can do this right from the geometry. I see that all of these are this line is the span of any vector on that line, any non-zero vector. So let's pick 1, 2. So that's W. And then you might think like, okay, well I can just find a vector orthogonal to that. And so so W perp would be the line that's perpendicular to that through the origin. We just need to get one vector there, so we can pick the span. So we can define that line as a span. So we could do 2 and a minus 1. Okay, so W perp is that's the basis vector, but we really should do the span of that. And that set, so W perp is that. So this line through there, that is W perp. Okay, that's solution number 1. Solution number 2. If we recognize the equation 2x minus y equals 0 as the equation of a line in R2, then in general form, then we can actually, well, we can read off a perpendicular vector. So the coefficients here, of 2 and a minus 1 give us a vector that's perpendicular to that line. So it is orthogonal to that line. And since we're in R2, there's only, and this defines one line, it's one dimension of R2, we only need one more dimension, and this vector will give us the point to the direction, that orthogonal perp direction. So we can pick the span. Notice it's the same thing, right? We just got it in a slightly different way. Span of 2 and a minus 1 equals W perp. Okay, so how about solution number 3? So this is the one that's much more general. Like, we were only able to use some of these because we could easily draw it on a plane, or it was in general form. So in general, we're going to end up using Theorem 5.10, which says that if I've got any matrix A, that's an m by n matrix, then So, well, the key here is we're going to write W as a matrix A. Okay, we want to, if we can write a subspace as a matrix, and the way we do that, we think of the basis vectors of the subspace as the columns or the rows of a matrix. Then we can use this theorem, which says that the row space of A, if we're trying to find the orthogonal complement of the row space of A, then that is the null space of A. So that tells us how to find the orthogonal complement of a row space. So if we have row vectors, or if we have a set of vectors, we can write them as row vectors in a matrix, then we can find the null space of that matrix. That is the orthogonal complement. Or the column space of A, if we want to find the orthogonal complement of the column space of A, then we find the null space of A transpose. So we can use this method, which isn't quite as slick. We had, because this is so simple, there were other ways we could do this. But in cases where it's not so simple, we have to go to Theorem 5.10. So, so what we're going to do is we're going to find a solution for, let's find a solution for 2x minus y equals 0. So let's write this as this, and row reduce. Well, we just have to divide by 2, so we just get this as our row reduced matrix. We have one pivot position here, so this is our free variable. So we'd get x equals 1/2 y, and y is a free variable, so y equals y. So that means all xy's that make that equation true are of the form 1/2 1, or it's easier to write it 1 2. We do that. Now notice that's the span of 1 2. We could already pull that out from this. We knew that if we had 1 2 and we took the span of that, that defines all of the solutions of that equation. So that's what we've done. We found the solution. So this is W right here. The span, or at least the span of all that, is the W. So if we write, so let's go use this theorem. If I write this as, if I write W as a column space or W as a row space, then I can use this. Let's write it as a column space. So, no, I lied. We're going to write it as a row space. No, we're going to write it as a column space. So the matrix 1 2, the column space of this matrix is, which is just that vector, it is that line. It is W. This line here that spans up, goes up and down. So so if I want to find, if this is W, the span of all that, then W perp by the theorem says, if I want to find the orthogonal complement of a column space, I want to find the null space of A transpose. So A transpose is 1 2, and I want to find the null space, so I'll augment it with 0, and then I solve and find the solutions here. All the solutions of this are the orthogonal complement of W. So it's already row reduced. That's nice. I've got a pivot position, I've got a free variable here, so x is equal to, pull that negative 2, that 2y over, so it would be a negative 2y, and y equals itself, because it's a free variable, so the basis vector will be a negative 2 1, or we could rewrite that as letting y equal t, be t times a negative 2 1. So this is the basis vector for W perp. So we can take the span of all that. The span of that is W perp. Now, you might say, Brother Corey, that's written a little different. Before we were getting spans of 2 and negative 1. You got spans of a negative 2 and 1. But that doesn't matter because they're still on the same line. One is pointing that direction and one is just pointing this direction. Oops, my line's not very good. So it doesn't matter. The span of either of those is still is the same line. So so there were 3 different ways to find W perp on number 1. The most powerful one is this one. It's not the slickest way, But the most powerful one is using that theorem 5.10 because it's more. You can do that for more general cases, things where our strategies from up here wouldn't work. All right, I hope that's helpful. Thanks.